Tech giants are currently investing tens of billions into artificial intelligence startups, targeting multi-trillion-dollar goals for custom chips and robotic factories. Adoption rates for these tools are currently breaking historical records as automated logic expands into every sector of the modern economy. In 1950, this reality was purely theoretical. British mathematician Alan Turing began his work by asking a question that most scientists considered a fantasy: can machines think? During World War II, Turing developed the first modern computer to crack the Enigma, a Nazi encryption machine thought to be unbreakable. While he proved that mechanical devices could perform high-level logic, a functioning digital brain remained decades away. Intelligence requires three specific components to function in unison: a software model, the training data to fill it, and the raw compute power to run the calculations. The history of artificial intelligence is the story of humanity spending a century building these three separate pillars in complete isolation. Early computing faced a massive hardware bottleneck. Machines relied on warehouse-sized arrays of vacuum tubes that required constant manual maintenance and frequently burned out during operation. Physicist Bill Shockley addressed this in 1947 by using germanium to create the semiconductor. His invention, the transistor, effectively shrank the power of a warehouse computer down to the size of a kernel of corn. Mass production remained difficult until 8 engineers defected from Shockley's company to form Fairchild Semiconductor. They developed the planar process, adding a protective coating to silicon that stabilized the fragile components and allowed for reliable manufacturing. This stabilization allowed engineers to pack multiple transistors into an integrated circuit. Eventually, Intel developed the microprocessor, providing enough compact power to move computers from the laboratory onto the consumer desk. By solving the physical hardware requirements, engineers forged the compute pillar, creating the digital engine necessary to power a synthetic brain. While hardware capacity grew, software development lagged behind. Programmers in the 1960s built chatbots like Eliza that used basic pattern matching to simulate conversation, but these systems lacked any true understanding of the information they processed. A breakthrough arrived in 1986 when Geoffrey Hinton developed backpropagation. When the computer provides an incorrect answer, the algorithm sends corrections backward through the network, adjusting the weight of the digital synapses so the machine learns for its next attempt. This learning model required massive amounts of raw information to reach its potential. The internet boom provided this, as companies like Google and Amazon generated more digital text and imagery than humanity had produced in the previous century. By the early 2000s, researchers possessed the software models to learn and the data to train them, but they still lacked the sheer processing power required to execute both at scale. The final collision occurred in 2012. Dr. Fei-Fei Li launched the ImageNet competition, providing the world's largest open-source dataset for researchers to test their object recognition algorithms. Geoffrey Hinton and his students entered the contest using a new, highly complex model called a convolutional neural network, or CNN. To process the millions of images in the dataset, they utilized NVIDIA graphics processing units. Jensen Huang's chips, originally built for gaming, were uniquely capable of performing thousands of mathematical operations simultaneously. The combination of ImageNet data, CNN models, and NVIDIA compute power shattered all previous performance benchmarks. This result validated the three-pillar formula, demonstrating that intelligence could be achieved by scaling these three components in unison. The AI community identifies this 2012 convergence as the Big Bang, the specific moment when isolated technological paths finally merged into a functioning system. Google immediately acquired Hinton's company and DeepMind to monopolize the best AI talent, while NVIDIA pivoted its entire business model toward building specialized AI chips. History had already shown that combining massive compute with deep datasets could achieve superhuman results, as seen when IBM's Deep Blue defeated the world chess champion in 1997. Google's aggressive consolidation of AI research sparked an ideological panic in Silicon Valley. Figures like Elon Musk feared that a single, closed-source corporation controlling superintelligence posed a systemic risk to the public. This fear led to the founding of OpenAI, a nonprofit designed to counter corporate monopolies by building artificial general intelligence safely and making the research accessible to the world. In 2017, a new software model called a transformer changed the landscape again. Unlike previous systems, transformers can process vast amounts of text data in parallel, allowing them to understand context and relationships at an unprecedented speed. OpenAI CEO Sam Altman realized that training these massive models required billions of dollars in compute power. The company moved away from its open-source roots to secure a partnership with Microsoft, using their massive server arrays to train the transformer model that became ChatGPT. ChatGPT became the fastest-growing application in history, triggering a global race to deploy generative AI across audio, video, and text. This aggressive trajectory is the compounding result of a century spent perfecting hardware, software, and human data. We have moved past the era of theory and into an exponential curve that is only just beginning to accelerate.